Hello everyone, I'm Haotian Zheng, and this is a poster version of my lecture. Before start, I want to thank all the contributors for my research. And the title is Surrogate-based sensitivity analysis and inversion for tunnel construction. An urban tunnel is a complex system with high risks to build, and just like other engineering design principles, computer simulation is a third discipline to link the theory with the practice or experiment. But current our tunnel design is struggling to balance the efficiency with the cost of the numerical simulation. Well, unlike other engineering design, instead of a one-shot product delivery, tunnel design is more like an adaptive process, which will and should be updated according to the construction responses. And in my PhD studies, I have been trying to answer these questions. How can we better incorporate uncertainties into current tunnel design procedure? And is there any efficient way to represent the expensive numerical simulation? And how can we better utilize the field measurements to help tunnel design and construction decisions? And here's how I have done this. For given tunnel project, we start with a 3D numerical model. And after studying the inputs and their distributions, we can train a surrogate model to replace a numerical one, which will benefit the following processes, like a global sensitivity analysis and the inversion procedures. And then we can update our parameters to generate a new evaluation for the future construction process. And the general idea of uncertainty quantification is to compile and interpret all the statistical information for input factors. And for tunnel construction, we mainly consider two parts: ground material properties and the construction variables. The first step of a surrogate modeling is to build a high-fidelity deterministic model, which means it should be delicate enough to represent realistically physical processes. And to simulate a tunnel construction, basically we need to take care of three aspects: the ground behavior, and the tunnel support realization, and the interaction between them. The second step is to train our surrogate model. Now, after comparing 4 different surrogate methods, we found that the polynomial chaos kriging has the best performance for our cases. And with the help of above surrogate model, here shows what we can benefit from the global sensitivity analysis. And it's a clear visualization of the importance ranking for the parameters, and also a relationship of their interactions. We apply this procedure to a real tunnel project constructed in downtown LA. And I was working with the excavation team there and collect all the field measurement data. And in the beginning construction, we use observed measurements to back analyze the ground properties and generated new evaluations for the tunneling responses, which help the contractors to make decisions for the following construction sequences. And this work is important in bringing confidence to every parties in a tunnel team, and also add to a growing body of research in reliability-based design framework for tunneling. And that's all my presentation. Thanks for the support, and stay safe and healthy. If you have any questions or comments, please email me. And I'm also waiting to share my poster with you if you are interested. Thanks again.